Welcome back, everyone. So for this lesson, we're going to be talking about graphing polar curves. Now, more specifically, what we're going to be doing is we're going to be given a rectangular trig equation, and then what we're going to do is we're going to reconfigure the graph, and then we're going to graph it on a polar curve, or on a polar graph, rather. So we give you the equation y equals 6 cosine x. Now, keep in mind, when the equations are written in terms of x and y, that means that the equation given is going to be given rectangularly. So you may need to rewrite your equation in terms of polar. So what that means you're going to do is your y values are going to become r values, and then your x values are going to become theta. So now we're going to have 6 cosine of theta. So I'm going to graph this first on a rectangular grid. So our period here is still going to be 2 pi. So we're going to be plotting our values at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that's where all of our points are going to be. So we have an amplitude of 6 and then a midline of 0. So we're going to use the line y equals 0 as kind of our midline, and then we're going to go 6 above and 6 below as we graph our equation. So with the equation 6 cosine x, we're going to start at a high point, which is going to put us at 0, 6. And then we're going to go to a midpoint, which would be at pi over 2, 0. And then we're going to go to a low point, which would be pi, negative 6. And then back up to a midpoint, where the midline is. And then we're going to go up to a high point. So your graph would look something like this. Now I'm going to label each of these points. So this would happen at 0, 6. Then we're going to have pi over 2, 0. Then we're going to have pi, negative 6. Then we're going to have 3 pi over 2, 0. And lastly, we're going to have 2 pi, 6. So for the next part, now I actually want to write all these values on a table. But for the table, I don't want just the x, y values. I want to write my coordinates in terms of r and theta. So when we did our coordinates rectangularly, we're going to reconfigure our values and write them in terms of r theta. So what's going to happen is my x value is actually going to be the angle, or the direction rather, that we're going to go. And then your y value is actually going to become the distance from the pole. So we're going to flip the x and the y to write r, theta, which means my coordinates, I have 0, 6, but for the polar coordinate, it's going to be 6 in the direction of 0 degrees. So I'm going to go a distance of 6 from the pole, and then I'm going to go towards 0 degrees. So for my next coordinate, I'm going to have pi over 2, 0, and it's going to be reconfigured to be a distance of 0 in the direction of pi over 2, which is just going to put us at the pole. And then for the next point, at pi, negative 6, now we're going to have a distance of negative 6 in the direction of pi. And then for your next point, we're going to have 3 pi over 2, 0, which is going to go 0 in the direction of 3 pi over 2. And lastly, we're going to have 2 pi, 6, which is going to go 6 in the direction of 2 pi. So when I plot these points, 6 in the direction of 0, it's going to be right over here. And then for the next point, we're going to go 0 in the direction of pi over 2. So whenever the distance from the pole is 0, that means we're just going to have a point at the pole. And then for the next point, we have negative 6, pi. So I'm going to go 6 in the direction of pi. However, because it's negative, it's actually going to go on the other side, and it's going to be reflected. So it's actually just going to be this point where we started. So really, there's no other point. So hopefully, as you notice, what's going to happen as we keep plotting more and more of these points, we're actually just going to oscillate back and forth between these two existing points on my polar graph. So what's going to happen, as I go counterclockwise on my grid, as we get closer and closer to pi over 2, the distance is going to be 0, which tells me I'm going to go this way, and then I'm going to get close to the pole as I keep rotating. And then what's going to happen, because my values become negative, then we're going to pass through the pole and it's going to get reflected. So what's going to happen is my grid, or my graph rather, is actually going to be a circle. So we're going to start at the point 6 in the direction of 0, and then we're going to go in the direction that follows these arrows. So now for the next graph, we're going to do the same idea. Now each of these trig graphs that we have, so now we have y equals 5 minus 5 sine of x, then we're going to have y equals 3 plus 5 sine x, so on and so on. Each of these trig equations is going to generate a different type of polar graph, which we're going to get more to the specifics later on. So over here, now with number 2, you'll notice that our equation actually isn't written in an order that we're used to. I know with these trig equations, we're actually used to seeing our equations written in the form a sine bx minus c plus d, where we have a as our amplitude, b is going to impact our period, c is going to be the phase shift, and d is going to be your midline. So if you look at your equation down here, I'm actually going to rewrite this, or actually first off, I'm going to change these to 4s so that it actually fits on my graph. So really, when I rewrite this, this should actually be negative 4 sine of x plus 4. So here, when I rewrite it like this, you can see that we're going to have a midline of positive 4, an amplitude of 4, and we also are going to have a reflection over the x-axis. So now I'm going to rewrite this equation in terms of polar, which means we're going to have it in terms of r and theta. So we're going to have r equals 4 minus 4 sine of theta. So if you want to, you are more than welcome to actually plot your midline. Whenever the midline is not 0, I personally like graphing my midline, but it's totally your call. So here's my midline. Now my point tells me, or my graph tells me, I'm going to have a sine graph. So I'm going to start in the middle at the midline. And then because it's negative, I'm going to go mid, low, mid, high, mid. So from this middle point, then I'm going to go to a low point, which I'm going to reference the amplitude. So I'm going to go 4 below the midline. So 1, 2, 3, 4. So now I'm going to put a point at pi over 2 comma 0. And then we're going to go back up to the midline at pi. And then at 3 pi over 2, then we're going to go up to a high point, which is going to happen at 8, which is why I changed it to 4 and 4. Because if it was 5 and 5, it would go up to 10. And my graph only goes up to 8. And then I'm going to come back down to a midpoint. So my graph will look something like that. I kind of missed. I'll do it again. I'm not sure if that's better or worse, but you know what? We'll take it. So I actually invite you to pause here and actually generate the table yourself and then plot your polar graph. Don't actually draw the graph yet. I want to actually draw the polar graph with you. Okay, so let's go ahead and label these points. So from the table, or actually rather from the rectangular graph, I'm going to generate the table. Now I'm actually going to go straight into the table. I'm not going to label my points because I want you to get in the habit of being able to just go from one thing to the other without too many steps in between, because I want you to be able to save some time when possible. So my first point is going to be 0, 4, which means I'm going to have 4 in the direction of 0, so a distance of 4 in the direction of 0 degrees, and then I'm going to have 0 in the direction of pi over 2, and then I'm going to go a distance of 4 in the direction of pi. Then I'm going to go 8 in the direction of 3 pi over 2. And then I want to go 4 in the direction of 2 pi. Now, one thing I did forget to mention on number 1, my apologies, I'm going to come back up here, I just thought about it. So over here, whenever we cross the x-axis on our rectangular graph, that's actually a very important little detail, because what that tells us is we're actually going to cross the pole when we do a polar graph. So this tells us here, since we have 2 x-intercepts, when we do the when we are doing the polar graph, we are actually going to pass through the pole. So we can include the pole in this graph. So on this graph over here, on number 2, notice how we are going to have an x-intercept, despite how bad my graph is. We are going to have an x-intercept, which means we are going to include the pole in the polar graph. So now I'm going to go to my polar graph. So now I'm going to plot these points. So 4 in the direction of 0. And then we're going to have 0 in the direction of pi over 2, which is going to be the pole. And then we have 4 in the direction of pi. Then 8 in the direction of 3 pi over 2. And 4, comma, 2 pi, which is going to put us right back at the initial part. So what this tells me, based on these values, I'm going to start at 6, comma 0. Well, rather, not 6, hello. I'm going to start with a distance of 4 in the direction of 0 degrees. And then we're going to venture over to this point in the pole, and then we come over here, and then we go down to this point over here, and then we are going to circle back. So what the graph is going to look like is it's actually going to be very circular in shape, but the shape of the graph is actually going to give it more of a heart shape. So what's going to happen, the way that I like to draw this, is I like to draw a circle, put the bottom part of that circle on that lower point, and then I'm going to raise up this circle so that the circle is going to pass through these two side points over here. And then once I do that, I'm going to use my eraser. I'm going to come over here to the partial eraser, and I'm going to erase just a little bit above each of those points so that I can get rid of this segment up here. So it's going to be completely circular in shape over here, except for this top part over here. So this top part is going to be more heart-shaped. So it's going to look something like this. And we're going to get into the name of all these graphs in a bit. So we start at this point at 4 in the direction of 0, and then we're going to follow the path that these arrows are indicating. So now for the next one. So we have y equals 3 plus 5 sine of x. So once again, over here, I'm going to do my midline of 3, and then we have an amplitude of 5. So I'm going to go ahead and draw my midline of 3. And then I'm going to do an amplitude of 5. Well, actually, let me write the polar equation first. So this would be r equals 3 plus 5 sine theta. So over here, I'm going to start at a midpoint since we're doing a positive sign, and then we're going to go up with an amplitude of 5. So 1, 2, 3, 4, 5. We're going to be at the very tip top. So a midpoint to a high point, then back to a midpoint, and then we're going to go to a low point. So I'm going to count 1, 2, 3, 4, 5 below, and then back to a midpoint. So my graph will look something like this. So once again, I'm going to generate my table, which I think a table will be easier to have on this problem because it's going to be a little funky. Now, keep in mind, we do cross the x-axis, which this tells me we're going to cross the pole. So now when I write my points, so this point right here would be 0, 3, which means I'm going to go a distance of 3 in the direction of 0 degrees. And then for the next one, I'm going to have pi over 2, 8. So I'm going to go a distance of 8 in the direction of pi over 2. And then for the next point, I have 3, pi, which means I'm going to go 3 in the direction of pi. And then I have the point 3 pi over 2, negative 2, which means I'm going to go a distance of negative 2 in the direction of 3 pi over 2. And then I have a value of 3 in the direction of 2 pi. So when I go and plot these points, we're going to go 3, 0, or 3 in the direction of 0. Need to get out of the habit of doing all that. And then I'm going to go 8 in the direction of pi over 2. Then I'm going to go 3 in the direction of pi. Then negative 2 in the direction of 3 pi over 2. Now, because it's negative, that tells me I'm going to go the opposite way. So rather than going in the direction of 3 pi over 2, I'm actually going to go in the direction of pi over 2. So that means I want 2 above. And then I'm going to go back to 2 pi, or 3, 2 pi, which puts me back at the starting point. Now, notice how I don't have a point specifically for the pole, but my graph over here tells me I do include the pole. So I'm going to go ahead and put a point at the pole. So what's going to happen is we're going to start at this point over here, we're going to circle all the way back over here towards the top, circle back down towards this point, and then we're going to pass through the pole and then loop around. So this graph, once again, it's going to look like this, kind of. It's going to be way more circular, but hopefully you get the idea. So when I draw my graph, I'm going to put this circle at the top, bring it all the way down, just like I did before, and then use my partial eraser, get rid of these parts. And then for this part, this is going to be what we call the inner loop, which we'll get to later on. But I'm going to start here. We're going to circle through the pole, through this point, back through the pole, and then connect it over here. So what I'm going to do, draw, pass through the pole, pass through this point, back through the pole, and then back around. So I'm going to start, and then our arrows are going to go around just like this. So next, now we have 5 minus 4 cosine of x. So my equation here, when I rewrite in terms of polar, so we're going to have r equals 5 minus 4 cosine theta when I rewrite. And then I have a midline. Oh, this one's going to go off the graph a little bit, but that's okay. It's only by 1. So I'm going to have a midline at 5. And then we're going to have an amplitude of 4, but because we have a negative cosine, that tells us we're going to start at a low point. So I need to count with an amplitude of 4 to start at a low point. So from the midline, I'm going to count down 1, 2, 3, 4. So I'm going to have a point right here. And then from a low point, we're going to go to a midpoint. And then from the midpoint, we're going to go to a high point, which is going to be off the graph a bit, but it's okay. Then back to a midpoint, and then to a low point. So your graph will look like this. So once again, I'm going to just kind of quickly go through the table. So this tells us that we're going to have a distance of 1 in the direction of 0. And then we're going to go 5 in the direction of pi over 2. And then we're going to go, what was that, 9 in the direction of pi. And then we're going to go 5 in the direction of 3 pi over 2. And then we're going to go 1 in the direction of 2 pi. So when I plot these values, so 1 in the direction of 0, 5 in the direction pi over 2, 9 in the direction of pi. Then we're going to have 5 in the direction 3 pi over 2. Whoops, I can't count. There we go. And then we're going to go back to the starting point. Now notice how in this graph, we don't cross the x-intercept, or x-axis. So we do not cross the pole. Since there is no x-intercept. So when you draw your graph, we're going to start right at this point. And then we're going to jump up over, yes. Then we're going to jump up to this point up here. So we're going to circle around and then circle all the way around here, then back down here, and then we're going to come back to the initials. So it's going to be circular in shape for the most part, but it is going to have this little wavy thing that's going to happen. So I'm going to put my circle over here on the left side, then expand, then partial eraser, then erase, and then it's going to do this like little wavy thing right here. So it's going to wave and then come around. So it's really similar to the previous graph. So then I'm going to do my arrows. Ta-da. All right, now for my personal faves. Just kidding, they're actually not. They're pretty graphs, but I'm not a fan. But it's okay. So now we're going to have the equation y equals 6 cosine 2x. So what I notice here is that we have a b value, which is going to impact the period. So first, I'm going to rewrite this in terms of a polar graph. So this is going to be r equals 6 cosine of 2 theta. So when I graph, I'm going to focus on the period first. So the period is going to be 2 pi divided by the b value. And then the b value in my equation here is going to be 2, which means the period is going to be pi. So within an interval from 0 to pi, we're going to complete one full cycle. Now the next thing is I want to look at doing the spacing. Now when I say the spacing, this is just a fancy way of doing the scale for the x-axis. Is essentially what I'm doing. So when I do the spacing, what I do here is I'll do the period, and then I'll divide it by 4. So we just said the period was pi, so I'm going to do the period, which is pi, divided by 4. So I'm going to scale the x-axis and count by a factor of pi over 4. Now, if you look at your graph over here, notice how we already start at 0, and then we go pi over 2, pi, 3 pi over 2, and 2 pi. So we actually already have a good scale put in place. I'm just going to kind of build on it. So for my scale, we start at 0, and then half of pi over 2 is actually pi over 4. So instead of using every 4 values, or every 4 spaces, I'm going to use every 2 spaces. So we have 0 pi over 4 over here, 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and last but not least, then we have 2 pi. So what's going to happen here is I'm still going to start at a high point since we have cosine and I have an amplitude of 6. So I'm going to start at a high point of 6 and then go to a midpoint at pi over 4. And then pi over 2 is going to be a low point. Then at 3 pi over 4, we're going to go back to a midpoint. And then we're going to oscillate and go between those high, mid, low, mid, highs. So then a midpoint, then a low point, midpoint, and high point. So my graph will look something similar to this. Not bad for freehand. I missed a little bit, but it's okay. So now I'm going to write out my table. So my table, I'm going to write these values out. So this would be 6 in the direction of 0. And then I'm going to have 0 in the direction of pi over 4. So we are going to cross the pole here. And then we're going to have a direction or a distance of -6 in the direction of pi over 2. And then we're going to do a distance of 0 in the direction of 3 pi over 4. And then we're going to go 6 in the direction of pi. And then we're going to do 0 in the direction 5 pi over 4. Then we're going to do a distance of -6 in the direction 3 pi over 2. Wow, that was awful, but it's fine. And then we're going to go a distance of 0 in the direction 7 pi over 4. And then we're going to go a distance of 6 in the direction of 2 pi. So I'm going to label these points. So 6 in the direction of 0 is going to put us over here. 0 in the direction of pi over 4 is going to put us at the pole. And then when I do -6 comma pi over 2, so we want to go in the direction of pi over 2, but that negative tells us we're going to go the opposite way. So we're actually going to go towards 3 pi over 2. And then 0 comma 3 pi over 4 is going to put us back at the pole. So notice the order. We're going to go here, kind of circle back, and we're going to come around. And then we're going to come back to the pole. And then we're going to go 6 in the direction of pi. So then now our graph kind of looks like this, and then we're going to go back to the pole. And then we're going to do -6 in the direction of 3 pi over 2, which means we're going to go up towards pi over 2 since it's negative. And then we come back to the pole, and then we'd be back at the original starting point. So then here, this is where we would start. It's going to be this point right here. And then based on the order, so don't blink, don't look away. So we're going to start here, go up towards, we're not going to go down. So a common question I would get is, why am I going up and not down? So that's because your angles here, we're starting at 0 and going towards pi over 2, which means we're going to go up. So that means your graph is going to follow the sequence. Start here, towards the pole, then down, and then we're just going to kind of slowly go around. So now I want to draw it. So start, and just circle around. Wow, close enough. Then you need to also include your direction. So we're going to have our arrows. Which once I do the arrows, that's when a lot of people kind of look at me like, excuse me. So what I do to kind of help is I'll label each of these segments in the order that you should draw them. So segment 1, segment 2, segment 3, segment 4, segment 5, segment 6, segment 7, and then segment 8. That way you can kind of get an order as to what's the order of these that you should actually draw them in. So the order is going to matter. So we may ask you questions that pertain specifically to a domain. So you do need to know the order of which those values are going to happen. All right, and then over here, it's going to be the same idea. So I'd actually pause here and try this on your own first, but I'm just going to jump right in. So my equation here, we're going to do r equals 6 sine of 3 theta. Then I'm going to do the period. So the period is going to be 2 pi over the b value, which is just 2 pi over 3. And then I'm going to do the spacing, which is going to be 2 pi over 3, all divided by 4, which is going to be equivalent to doing 2 pi over 3 times a fourth, which is 2 pi over 12, which is pi over 6. So I'm actually going to count by pi over 6 on my x-axis. So if you look, the current scale I have is not going to be very helpful, so I'm just going to ignore this scale. If you need to alter your x-axis scale, that is completely okay. You are more than welcome to. So I'm going to count by pi over 6. So 0, 1 pi over 6, 2 pi over 6 is pi over 3. 3 pi over 6 is going to be pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6. 6 pi over 6, which is pi. 7 pi over 6. Then 8 pi over 6, which is 4 pi over 3. So when I graph, I have sine function. So I'm going to start at a middle point. So I have a midline of 0, so I'm going to start in the middle. And then I'm going to go up to a high point of 6. Then back to a midpoint. Then a low point. Then midpoint. And then, yeah, keep going. Oscillate. So your graph is going to look like this. Okay, now I'm going to do the table. So r comma theta. So I would say pause here, actually, if you need to, if you want some time to write them out, because I'm going to go through these as quick as I can. So we're going to start with the distance of 0 and the direction of 0. And then we're going to go a distance of 6 in the direction of pi over 6. And then we're going to go a distance of 0 in the direction of pi over 3. So we are going to include the pole. And then I want to go a distance of negative 6 in the direction pi over 2. And then I want to go a distance of 0 in the direction of 2 pi over 3. Then I want to go 6 in the direction 5 pi over 6. And then I want to go 0 in the direction of pi. Then I want to go negative 6 in the direction of 7 pi over 6. And then I want to go 0 in the direction of 4 pi over 3. So when I do this, we're going to start at the pole and then go 6 in the direction of pi over 6, which puts us over here. And then back to the pole. So we're going to start and do something like this. So that's your first pedal. And then I want negative 6 in the direction of pi over 2, which tells us we're actually going to go down towards 3 pi over 2. So as of now, your graph is going to look something like this. And then we're going to come back to the pole. So now we're going to be at 6 in the direction of 5 pi over 6, which is going to put us over here. And then we're going to go back to the pole from there. So we currently have this kind of layout. And then we would go back over here to the starting point. Or not the starting point, since we started the pole. So we started the poll, and then based on this drawing, oop, I missed. I still kind of missed, but it's okay. Close enough. So now I'm going to do my arrows. Wow, this is actually quite terrible, but you know what? It's fine. So the order of these little segments are going to go 1, 2, 3, 4, 5, and 6. So that is going to be graphing from rectangular going to polar. So I'm going to make this video 2 parts. This is just going to be part 1. Part 2 is going to include the rest of this. So have fun. Bye-bye.